Well, we're back again. Gee, that first video went so well, I figured I'm on a roll. I'll make a second one for today anyway. As we progress from the exterior and now get into the basement, just a few things I'd like to point out. We're looking at a sump pump. For those of you who don't know or don't have one, this is probably a good place to just give a quick review. Basically, what the sump pump does, obviously, is collect water from the exterior of the foundations so your basement doesn't flood. Just some key things I'd like to point out in here. This might be a little different than any configurations you have because this particular pipe right here is a passive radon system. I'll explain that in class. And most circumstances, sump pumps would not necessarily have this particular pipe inserted. Normally there's just one exterior pipe that would come out. It's this PVC one here. This is basically a clamp I put on here, so in the event I want to switch it out because it fails. I'll explain that in class too real quick. But for the most part, it ejects out, and this particular piece right here is called a check valve. And the check valve is used to keep water that would fall back in the tube from falling back into the pit. So basically there's water, my finger here, all the way up in this particular pipe here, and it comes down and it stops right here at this check valve. And that prevents water from falling back in. You always want to make sure that you're plugged in properly and that you only have one plug in the outlet and that you don't have a dehumidifier or anything else plugged in there because you don't want it to trip. I'm not going to take this thing apart, but for the most part there's a pump in there, and that when the water fills up to a certain level, the float rises, it operates the pump, and it evacuates the water, pumps it out. Over here, you'll notice I have a backup. I changed this pump about every 3 years. Of course, I've only been here 3 years, but I just recently changed this. This particular pump works fine, and it's what I call my hot spare. So in event in some crazy rainstorm my pump was to fail on me, this one is already set to go, and you can see it's used, and you can see I've even got all the old existing piping connected to it. So basically I would just pop the lid, drop this guy in, and connect it up. That's what this plastic or this rubber connector is. I would loosen that, pull the old one out, pop the hot spare in. So enough about the sump pump. Let's continue to move on here. And I want to talk about water heaters because we have an actually good example that we'll talk about from one of our students who I had the pleasure to speak with over the weekend. But basically, it's a little dark in here. So the key things that you want to do with your water heater, we have two here for instance, but for the most part, is if you look closely, this is the drain. And I would recommend that every 6 months or so, it could be 3 months, depends on how hard your water is, that you would want to take 3 or 4 gallons of water out of there to get all the hardness and any sediment out of there. If by chance you had to replace this, needless to say, your connections would have to be disconnected both here and then up at the top, both your hot and cold. And then, of course, your B vent, which is what exhausts it up through the roof. Some key things is this is your pressure relief valve, temperature pressure relief valve, and it should have a pipe that extends about 6 inches from the floor. So if, God forbid, it ever goes off, it's not going to scald you. Hopefully you have a floor drain, which is located right here, and any water that would come out of the tank or leak would go into the floor drain. That's perhaps the most key thing. And the second thing I'd want to mention too is that you have a joint that is not corrosive, and this would be a non-metallic joint. If you look real close, you kind of can't see it, but there would be like a plastic or rubber sleeve that would transfer from the copper to the galvanized pipe, so you don't get any electrolysis, which would corrode, et cetera, et cetera. But the important thing is to inspect, make sure you don't have any leaks, usually at the base, and that I would recommend that you keep the water set at like a medium setting. And that should do it for water tanks, and we can talk about that more at length because we have an example of someone who is swapping one out, and hopefully we can get some good ideas from that particular project.